Hi folks, can you all hear me all right?
Yep.
Perfect. As David said, my name's Laura Kelly. I'm a software engineer at Rapid7. Been there for about 3 years now between internships, part-time work, and now back as an SE1 grad. And I'm going to talk a little bit today about DynamoDB, the good, the bad, and the gotchas. When Dynamo is good, it is great. When it is bad, it is painful. And there are pitfalls and gotchas that are absolutely going to get you. But before we kind of take a dive into DynamoDB, I want to give a bit of context around this. So this is a fantastic quote from Peter Sondergaard. He's a senior vice president at Gartner Research. Information is the oil of the 21st century, and analytics is the combustion engine. I really want to use this to highlight that in the tech industry, everything that we do is about data. Whether you're a data analyst, data engineer, software engineer, business analyst, whatever it may be, it is all about exposing data, retrieving it, ingesting it, kicking off events as a result of it, mapping it, deleting it, whatever it may be. Everything we do surrounds data. So it's no surprise then that every architectural decision we make is around how do we store that data? How do we map it? How do we get it from A to B? So that leads us to database considerations. It's not enough anymore that a database or a data store just works. In the same way that information is the oil of the 21st century, the cars that are on the road 40 years ago are not on the road today. The databases that worked 5, 10, 15 years ago are not suitable for today's applications. So when it comes to choosing new architectures, new databases, new resilient architectures for a modern application, it's important to make some database considerations. Things like cost, scalability, your data availability, the latency. Obviously, we want everything to be faster. The engineering effort associated with managing that data, the security of the data. I work for Rapid7. Cybersecurity is always going to be a massive consideration in every application we have. Available integrations. How does your database fit into your existing architecture? And maintainability. Obviously, no application goes out into the world and is left alone. We want something that's easy to maintain going forward to give our customers, to give our stakeholders the best experience possible. So in a world where cost and latency and effort are constantly at war with each other, this is where Dynamo comes in. What is Dynamo? It's AWS's preferred database offering for your fast, small data models. It's a NoSQL key value database, pretty much meaning that you can treat Dynamo like a giant hash map. Bit fancier, but at the end of the day, it's all about your key queries. It's fully managed and serverless, meaning that all of the scalability considerations and complexities that you have with traditional relational databases, they're no longer a massive consideration for you as an engineer anymore. It's automatically replicated over 3 availability zones. If you have customers who are constantly asking for data, constantly retrieving, constantly querying for data, if you have a data store goes down, you want at least 2 backups there. Amazon automatically manages this for you. And you have proficient throughput model. So in a traditional relational database, it's all about the storage. A database with 10 gigs worth of storage obviously has a different cost consideration than a database with 10 petabytes of storage. With Dynamo, it doesn't matter. If I have a database that is tiny with 10 read capacity units, 10 write capacity units, it will cost me the exact same as if I had petabytes of data at that exact same throughput. Your traffic is a consideration. And with that, and with Dynamo's managed serverless model, you have predictable performance. Dynamo will boast single-digit millisecond latency. And again, we're in a world where customers and stakeholders want everything faster and yesterday. Latency is a massive consideration. So how is Dynamo different to a relational database? There's a couple of key points here I really want to highlight that are going to be massive when it comes to designing your data model, designing your schema, and moving forward with Dynamo or a relational database as your architecture. Firstly, a relational database requires a relational data model with a well-defined normalized schema. You're thinking about tables, you're thinking about joins, your one-to-many or many-to-many relationships. This all needs to be considered up front. Dynamo is technically schemaless. You have to worry about your keys, but there is no explicit model constraints for any non-key attributes. This is where Dynamo becomes a little bit more complex. You have no well-defined schema anymore to help predict your queries. You have to think about your keys and only your keys going forward. For relational databases, SQL is the standard for storing and retrieving data. SQL is the Marmite of the tech industry. You love it or you hate it. Everybody has worked with it at some stage of the race. And it's a standard for a reason. It provides a lot of flexibility, it provides a lot of querying power, but that then comes with the complexity of how do your queries scale? when you add joins, when you have different tables, different query restraints, how does that affect the performance of those queries? With DynamoDB, it's a little bit different. You can use the AWS console, you can use the CLI, you can use PartyQL, which is a SQL-compatible language that's you can use with Dynamo. There's a number of different object-oriented SDKs, and you can use NoSQL Workbench as well. And these can all be used for storing and retrieving your data from a Dynamo database. As I've said before, relational databases, they're optimized for storage, and the cost then is also related to storage. So the queries must be optimized to achieve peak performance. This is where the complexity of a relational database really comes to hit home and bite a lot of people in the backside. You have a database of 10 gig. You have a query, a simple SQL query that will execute in milliseconds. In 5 years' time, when that database is holding terabytes of data and you're having complex joins and your queries are suddenly much slower, the complexity comes in then how are you optimizing those queries for performance. DynamoDB is optimized for compute, on the other hand. So performance is a function of hardware and network latency. But because Amazon manages all of this for us, as engineers, we do not care. All we care about is what our queries look like in our code. For relational database, scalability is easier with faster hardware. You can distribute your systems, but this is a massive cost implication and a massive complexity implication. But once again, Dynamo is designed to scale out using distributed clusters. And again, Amazon manages all of this for us. You can allow for increased throughput without that latency degradation with Amazon's. To be honest, the throughput model with Amazon provides a lot of flexibility when it comes to your querying and becomes to your scalability. And I've already mentioned the cost considerations relating to storage and relating to throughput already. So with all this been said, is Dynamo a better database than a traditional relational database? I don't know. There's no one true database to rule them all. If there was, Amazon and Google and Azure would cost an absolute, or charge an absolute fortune for it. I'm not going to tell you what database is best for your application. There's going to be a number of considerations there around query flexibility, around storage, around throughput, around cost. But what I'm going to say is I'm going to assume for the remainder of this talk, you've all jumped on the Dynamo train with me and you're going to go away tomorrow and start migrating all of your Postgres DBs to Dynamo. What are the considerations you need to make around that? So I've already said, Dynamo's a NoSQL database. If it's not using SQL, how exactly am I going about querying my data? I've mentioned already the various tools that you can use in terms of retrieving and storing your data with DynamoDB. But the one thing I really want to highlight here is it's all key-based queries. The keys are king when it comes to Dynamo. You live by your keys, you die by your keys. They can either save you or they can cause you a lot of pain. So this is where query-first approaches to Dynamo can inform how your key schema looks. With a relational database, your complexity comes from SQL, from scalability. It comes further down the road from your initial engineering decisions. With Dynamo, your complexity is front-loaded. You get over the initial hurdle, you are plain sailing. If you have a poorly designed schema, you are in for a world of hurt. So let's go for the query-first approach to schema design. I know I said Dynamo is schemaless, but we do have a key schema to consider. So these are the questions that my team and work are sick of hearing about. Anytime there's a Dynamo project comes up, these are the 4 questions I tend to ask myself and ask other engineers. If there's one key takeaway I could get you to take away from tonight is if you're in a planning meeting, an architectural design meeting, or if you're even considering working with Dynamo, think about these 4 points. The first one, what data will I actually have when querying this table? So I'm going to say I have a pet peeve when it comes to examples in database talks. If I hear one more talk about customer order, invoice order, I am going to scream. Considering the Rugby World Cup starts tomorrow, we're going for a rugby example because I don't think Rapid7 wants me to give away all of the trade secrets that it comes with the tickets that I initially worked with this. So we have a relational database model here. It's typically more representative of what the actual data looks like in real life. We have, as our primary key for this table, we have a player ID. This is a completely arbitrary, randomly generated ID that its sole purpose is used to uniquely identify any item in the table. We have other fields like country and position, surname, forename, so on. This is your typical relational DB model. For Dynamo, we're going to translate this slightly differently. With relational DBs, your data will typically represent the real-life application. With Dynamo, because your queries are a little bit more creative, our data model needs to get a little more creative. With Dynamo, you have what's known as a partition key and a sort key. Partition keys are compulsory. Every table has to have one. Sort keys are optional, but they provide a little bit of additional flexibility. So your partition key, as the name would suggest, is how Dynamo partitions your data. So whenever you have your lookups, which is what Dynamo is often quite used for in terms of looking up data very quickly, this is the first point of call. When querying Dynamo, when I'm thinking about what kind of data do I have, I always have to have my partition key value to be able to query Dynamo. In this case, in the terms of rugby, I want to get statistics about any given position. I want to know who the best players are in any position at any time in the World Cup. Think of this in terms of like a betting system, player performance statistics systems, whatever it may be. So I want to say, right, I want to know all the statistics about every single winger in this cup. I use a query with an equality operator on a partition key. The sort key here is where it gives me a little bit of additional flexibility. Your sort key can be a combination of any number of fields. I have done a bit of a combination between country and name here, and there's a reason why I'll show you later on. But this means that I can refine my query further by saying, right, I want all of the wingers who play for Ireland. I want all of the fly halves who play for England. And that gives you that little bit of additional flexibility in terms of, with a sort key, I can say with a string sort key, give me a begins with operator, give me an equality operator. It gets a little bit more flexibility. Like any database, your keys have to be unique. Either if you have partition key only tables, the partition key must be a unique value. If it's a partition and sort key combination, that's sufficient to be unique. But every single item in this table, like any other database, has to be uniquely identifiable by a key. So this is how I've translated this Dynamo model to this table. There's any number of ways based on how you're going to be querying your data, how you could model for Dynamo. So because I want to know about positions first and about country second, this is how I've modeled it. We'll change it about a little bit later on. We'll introduce indexes in terms of query flexibility, but this kind of leads to the first pain point. Poor schema design can and will lead to a lot of operational pain when querying your DynamoDB indexes or tables. When we're talking about resilient systems, we want to think about future-proofing our table. This can be somewhat difficult with Dynamo. This is why your complexity is front-loaded. If you get a really, really, really good schema design up front, Dynamo can be a really scalable and maintainable solution for your resilient applications for years to come. You get it wrong now, in a month's time, you're going to be switching it over. My very first ticket as a baby intern in Rapid7, first week in, was just to help migrate from PostgreSDB to a Dynamo table. And we had a one-to-one relational model between the initial PostgreSDB and the Dynamo one. Player key was our partition key. We did use the position as sort key there. And what was meant to be a 2-week ticket lasted 4 months. In essence, we tried to fit a square peg in a round hole. The architecture, the model, the design was all initially intended for a relational model, and it didn't work. I spent 4 months shaving the corners off that peg to get it into the round hole, and eventually realized that your architecture is going to have to significantly shift when working with DynamoDB. Well, when I say significantly shift, I mean how you're storing, how you're querying, the actual data management portions of this. Your ingestion pipelines and whatnot can all remain the same. So design your schema well up front. Second question is going to be, how unique is the data I'm going to be using to query this table? So we'll go back to our data model here. With Dynamo, you have to be aware of your hot partitions. So with a Rugby World Cup example, anybody who's not familiar with rugby, you have about 15 positions in the field, give or take. So there's going to be at least 15 different partitions in this table. It's going to be reasonably well distributed based on the queries that I, as the software engineer, know that I'm going to be performing. So winger is a reasonably good partition key for this table. If I was to go, for example, for the status as the partition key, I only have 3 statuses there. Suddenly now I'm reducing my number of partitions massively, and you have the potential for, say for example, the likes of active, which is going to apply to most of the players in this table, to become a very, very, very hot partitions. This leads to the second pain point. Choosing a partition key with low cardinality will cause hot partitions. It will cause confusing throttling errors, and it's going to cause headaches. So going back to this model for a second, if I had chosen status as my partition key, I could get to a point where this is a scenario that we have with a different Dynamo table. We have provisioned a Dynamo table with about 8,000 read capacity units. Dynamo has a limit per partition of 4,000 read capacity units. That's a hard limit that AWS enforces. So we were getting these throttling errors. We were going, right, let's look at the capacity for the table. Looked fine. We were only using about 4,500 units. We're like, we're nowhere near our max limit here. Why are we being partitioned? Why are we being throttled? We had one very hot partition that caused about a week's worth of headaches in terms of why is this happening? We weren't getting a lot of context in the error messages, and it was only eventually when we did a deep dive into documentation that we realized this. Choosing a correct partition key, choosing a sensible high cardinality value for your partition key is going to save you a lot of time, it's going to save you a lot of confusing errors, and it's going to save you a lot of money in terms of headache tablets at the end of the day. Third question, how many different ways will I want to try and query this table? One of the reasons that SQL has been so successful over the years, it gives you a lot of flexibility when querying. I can do any number of where clauses, I can do joins, I can do any number of types of comparison operators. Dynamo is a giant hash map. You just have your keys to work with. So how many different ways do you want to query this table? So I have an example here of where I've switched the values for my partition key and sort key, depending on what the context is going to be. This is where, again, a good key schema design up front is massively important. If I want to know statistics about particular countries, and that's going to be my most common query throughout the usage of this table, then country is a far more appropriate partition key than position is going to be. This is where, again, the Dynamo data model doesn't necessarily have to be exactly representative of the real life application of this data. You've got to be flexible in your query models so that you can have good queries. And the last question, I promise this is actually the last one, is what conditions will I want to impose on these queries? This is where your where clauses, your conditional operators are in SQL are very, very attractive. And this is where Dynamo can get a little bit hairy. So I have a main table here and I have an index. Dynamo provides two different types of indexes out of the box, a local secondary index and a global secondary index. That's a talk in itself. The long and the short of it is indexes are pretty much a copy of your table with different keys. Amazon will automatically automatically maintain the data consistency between your index and your table. You don't have to worry about that. So if I wanted, for example, from a refereeing perspective in this World Cup, to say any player with 2 red cards is on their last warning and they need to be brought in for a disciplinary meeting. I can't do that query with my main table right now. I can't do it. It's a non-key attribute. As far as Dynamo is concerned, it's not there. It doesn't exist. So I have to create an index. Because my partition key here is going to be reds, it's going to be the number of red cards. I'm going to know that up front when I'm querying. I have to have a reasonably unique value to, in conjunction, uniquely identify each item in this table. So I've went for country name again. And using this, I can project forward a number of different non-key attributes from my main table, for instance, status, into my index. Your keys from your main table will always be projected through. This kind of leads to the third pain point. Indexes do put a throughput strain on the main table that you have to take into consideration whenever you're provisioning your capacity. Whenever we were doing our Postgres DB migration, we said, right, there's 2 main scenarios we want to query based on here. The first one we had handled in our key schema design for the main table. The second one was going to require an index. I provisioned this index, I decided on a good key schema, I was going well, and I hit provision. And it said, this will be complete in 4.5 days. Bit too slow for my liking. One of the pain points that we had considered there was that the main table was going to be throttled in terms of its reads, while the index was going to struggle in terms of writes. So the solution to that was bump them up. We had, the table was about 8,000 read capacity units. The index was provisioned for about 2,000 writes. We bumped both of them up to 20,000 for about 4 hours, got the index provision, then put them back down. Did it cost a little bit extra money in the meantime? Yes. But 4.5 days where the reads on our main table was being battered wasn't acceptable for our current solution because it was in production. So just be aware that indexes, even the maintenance of indexes with Dynamo copying your items from your main table to your index, will put a throughput strain on your main table and on the indexes. And the last pain point, Dynamo is restrictive in its querying. I think I've hammered that home enough already. But we can't do any pre-query filtering outside of the sort key. So I've talked already, your partition key has to be an equality operator. Your sort key can be a begins with, it can be a quality operator. Unfortunately, it can't be a contains or an ends with due to AWS's querying model. So you're pretty restricted even with the number of indexes that you have on how you actually query this data. I have an example here. I have padded out my main table with a little bit more data to highlight the point. And we've got further on into the competition. Rather than players being banned, now teams have just been knocked out. We're out of the group stages. Wales and England have been knocked out, and there's my World Cup predictions. So we have it now that Ireland, France are still in the competition, England and Wales are out, all is well with the world. And I want to have a bit of information about what players are actually still in the competition. So I have an index. I have status as my partition key because I want to know about active and injured players. And I have my keys from my main table projected through with country name as sort key and position as a non-key attribute. So if I want to know about active and injured players, that's two very separate queries. I have to run them both, or I can scan this table and do a post-query filter on knocked out. That's wasteful. If I do any kind of a query on this table and there's information there that I don't want to be getting back in my results set, Dynamo's got to give it back to me and say, right, here's your response. It's paginated for however many thousands of items you want. Let me take out the ones you don't want here, and I'm going to give you the data back. You've still used your consumed read capacity units there. And with Dynamo, because it's a throughput model, that's money you're wasting. So how do we get around this? Alternatively, you could just say, right, give me all the data. I'm going to personally paginate through it. I'm going to decide what I want out of that. Again, wasteful in terms of capacity units. Or we can get a little bit creative. For anyone who was at the last Serverless Days talk, Ryan and Lars gave a talk about Carpenter. This is the moment where Lars turned around to me and he went, you're right about this. And it was the greatest moment of my career so far. Because Dynamo, if you choose a non-key attribute to be a partition or sort key in your main table, it won't project that item through if it's null. With Dynamo, it doesn't care about anything that's not a key. Even when you're creating your tables, if you try to define an attribute that's not part of a key schema of a table or an index, it will complain and say, I don't care about it. I don't want to know. I'm not creating the table until it's gone. So I intentionally leave status blank. It's not null, it's just blank. Whenever I return any item that has a blank status here, it's not going to be even included in the JSON response. It just doesn't exist as far as Dynamo is concerned. When I use status to project to my index, it means because there's no actual value here for status, status doesn't exist for these items don't exist in the main table. Suddenly I have an index where none of the knocked out players are even considered anymore. Owen Farrell, Dan Bigger, any other knocked out player here will not be returned in my data set. I can now perform a normal query, be efficient with my read capacity units, and ultimately reduce the cost. If you're using on-demand capacity with Dynamo, this is going to reduce your cost massively. These are some of the pain points, some of the elegant solutions. I really just wanted to hammer home the fact that Dynamo, when your complexity is front-loaded, can be very, very intimidating at the start, especially if you've been using SQL for years. But you can get around it. If you're in a planning session, if you're in an architectural design meeting, these are the questions that I want you to ask. These are the questions I want you to ask yourself, your colleagues, anybody else. Thank you very much.